Hello everyone, this is Mr. 13 Things, specifically coming at a group of educators that we're working together with. We're all working together looking at Khan Academy, and this is an example of reviewing what was done in class or in the session today, and I'm going to point out what I'm doing and the software I'm using and go as quickly as I can. It will cover multiplying of a matrix and a vector. It will cover smooth draw. It will cover a TI-83 calculator, and it'll cover a little bit about capture. So the first thing I'm going to point out is smooth draw is already up behind on my machine. I'm using something called Camtasia, which is a pay great software. Cam Studio is freely available and a great way to capture. If you capture 1280 by 720, the upload up to YouTube is just so much easier. It's just a good idea to keep to these standard formats. It will push out the end file at various degrees of pixelization, depending on the end user. So what I'm going to do is show you the little trick that Sal Khan does. Is he right as said, go ahead and he goes change his canvas right away. He resizes. You never see this to 1280 by 720, and then eventually I'm clicking that down and then locks it up as he goes through. This is my presumption, unless he's making it with HT. So at the moment you don't see that canvas. It looks a little odd. What you also have to do if you really want to get things going is change the background, I think, to black. Changing it there, and change the foreground to some color you want. Did you see him doing off on the stage? Hit close. You see that here. I'm clicking to the color. You double click inside. Hit close. That's there, and now you have to do File New. That's a weird bit of that program. Save your picture. No. Now you've got basically that bit, and I'm going to try to get that somewhat in the correct location. Alright, that it is. So here's then the problem we did in class. It is, theoretically, I'm going to grab this. I'm controlling my pen size off on the left. I'm doing this with the mouse. Really, you got to, if you really start to doing this with any type of regularity, you've got to have some sort of pen input. Depending on the computer you have, that might work right off your trackpad. First concept we've talked about is, and this is actually the way it's done within a program called SketchUp when dealing with transformation matrices, keeping track of the locations in a list, a long list. 0, 1, 2, 3 was our first column vector. 4, 5, 6, 7 was our second column vector. 8, 9, 10, 11 was our third column vector, and 12, 13, can't read that, 14, my hand is already tired, just so you know, and 15. So that's the last column vector is 12 through 15, and then we have our vector on the outside, which I think we made to be, 1, 2, 3, which would be a standard XYZ coordinate. Down here we put the 1, which is usually what you carry around if you're doing basic 3D transformations on 3D point data. It's called a scale factor. So the question was, if this is matrix A, and this is the standard form that we very often see, A times X, and we call that usually equals to B. That's the way that when it's taught by Gilbert Strang at MIT, the way it's done. So AX equals B. If you're doing it in type font, these are bolded. It's just AX equals B with everything bolded. All right, and what we wanted to do in class, in the end, is just show how you can use a higher order concept as a game. I think some people call that the lattice method. And so what we did is we really know that this is the same. I'm going to write this down below here. It's the same. Remember we talked about this being a column vector, 0, 1, 2, 3, but there's also a row vector. And so that row vector, I'm going to just write now into a row vector v1. Okay. And this is a row vector v2. realize I'm counting. In this case, I started counting at 1, so this can, you could begin it with V0, V1, etc. But in this case, we're going to go V3, and in this case, V4. Sorry, V4. All right. Again, I'm pointing out my pen width is too wide, and in fact, I don't have a tablet. All right, so, and then this, of course, is a column vector. We'll call this V5. And V5 is a column vector, V1 is a row vector, and what in the end we wanted to do is basically the multiplication of the two is just a sum of all the row vectors. I'm going to say the V row vector, times, and that's a dot product, times V5. Right? So it's a sum of them, and that's how you get 1, 2, 3, 4. And so when I talked about putting the 1, 2, 3, and 1, it was the middle calculation. So the way we did this in the end, and the picture I'm pulling off of my camera is what we did in class, but I'm going to say we knew that we took everyone in the class, multiplied, and let's see if we can do this. The people who had the first column would have been a better way to explain it. People in the first column are going to multiply by the first row. People in the second column are going to multiply by the second row. People in the third column are going to multiply by the third row, and people in the fourth column are going to multiply by the fourth row. Stumbling through something like this is not a bad deal. So we're going to go through it necessarily, but my explanation in terms of this middle calculation was not the best. So I'm going to go through, try to find this on my phone, which I'm not going to be able to do, so I'm just going to do it by hand. So that, remember that 1, this turned out to be 0 in this case, and 1, and then 2, and then 3, and the second one was a doubling, if you think about it. Doubling, so this was 8, right? And then this was 10, and 12, and 14, and the next one would have been a tripling. No, that would be 24 and 27 and 30 and 33. And now we're back to this interesting vector. The first one, everything is going to be 1, so that vector becomes the same. 12, 13, 14, 15. And my problem and my issue here is this should not have that notation on it. Basically, that's not the operation. But then what we end up doing is we do the summation for each of these and we get our end solution. All right, so that's what we did in class. Later on, you will see that the concept, if you are covering rotations and dilations and scales and reflections somewhere in your curricula, or in the games the kids play, they will need to figure something like this out. So I'm going to try to get my thing back on. I'm jumping around here. Get that back kind of in the right spot. Usually if you lock this down is the best way to do it in Cam Studio or Camtasia. All right, so we've got that. So now let's see first off how you might generally do it the third, the fourth, the fifth time. Just like with multiplication, you would end up using another program. I would wholeheartedly recommend you look, and any educator beginning at least 7th grade and probably at 6th grade, depending on what the Common Core tells you, is what calculator you use. If in fact there is a shareable calculator out there put out by TI that your students can download to their home machines or you can get onto your school machines, I wholeheartedly recommend that. I don't think it'll take, but a lot of organizations start using those calculators around 7th grade. They are antiquated in many ways, but they still are allowed on many exams. And I'm trying to find it as I speak here. There it is. I'm going to bring it up. The Flash debugger, we're talking about, and provide that link to you. File, new, TI-83 Plus. I'm going to run that. Here's my calculator over here. Just, cancel. I don't want to do that. I'm going to minimize that. So now I got my calculator up here. I'm going to turn it on. All right, clear. on, and all of a sudden you realize that all that cord stuff that you used to have to do to kind of project your calculator is antiquated technology, but sometimes you got to work with what you got. I'm going to go ahead right away just to go into edit a matrix. Remember that matrix A? We're going to edit that, and we're going to make it a 4 by 4, 4 enter by 4, up here again, go back. So I want to go back. This is seizing on me a little bit. I'm going to hit turn it on again, second matrix, edit, enter, and I want to go 4 tab by 4 down, and I said 0, 1, 2, 3, 4, 5, 6, and this is the point where perhaps kids will start to say, well, that's not as good as my Xbox, or not as good as, and it isn't, but you can go to what we're all trying to do here, just kidding, is teaching to what you can use in an exam. It's also showing them some technology that's not so flashy, but it's pretty darn good technology. The space mission was designed and executed on computers that were not much more powerful than this. Depending on how you read, they were not this powerful. They might have been HPs with reverse Polish notation. 12, 13, 14, and 15. So we're looking at redundant systems now. We now have a matrix A that's made. We can say now second quit. And now we're going to make a matrix B. We can't really make a matrix X in this calculator, but that's fine. We're going to go second matrix, and we're going to go to B, and we're going to edit it. And this one did it wrong. Second quit, second matrix, B. Weird, you'll see I got to go down to B, hit enter, and then I'm going to make that, of course, a 4 by 1. Go down here, we said that was 1, 2, 3, and then back to 1 for the scale factor. And then second quit, and then all you need to do to multiply is hit second matrix A, and the implication of using one of these is not necessary. Second matrix B. I don't think it'll screw up though, and you get the answer we had in class. So I'm at 13 minutes here. That's twice as long. I've covered 2 topics. We can look at how to cut this video down into 2 pieces, but I will come back finally and show, as I go here, back to my general 2 ways to do that. You can go back, forth, and back. So let's check our math there. We have 8 and 24 is 32, and 12 is 44, yes. We have 37, 47, 51, that one's correct. We have 14, 34, 58, and we have 3, and at this point you want to do all the math because you want to show that you got to get trust with the calculator once or twice, but then after that you use the calculator or the spreadsheet a lot. So 3, 14, 33, and 15. Let's see if we can do that. 17 and 17 and 33, you got that whole borrow strategy, building up a house, a unit of 10, so you have 50, and 10 more is 65. So that's good. In the end, I will separate out the video, or we'll talk about how you can do that. Cutting up your videos yourself right in the middle of the topic is a useful thing to do, but if you have the right editing equipment, you'll see out at Udacity you can go a whole big run and then cut it up into pieces and kernelize it. Thanks for listening. We'll pick it up with a shared doc that does the same thing, because the intent is that you see that Google Docs is a lot more than sharing a regular document. The spreadsheet sharing and the ability to search stuff out on the web and link it live is tremendous, and it will have great ramifications when you deal with data, and you'll have more data in more formats in the next 10 years than you've had in the past. Thanks for listening.